Okay, so we want to do 7.1 number 10, which is the Ferris wheel and shift.
Yeah.
Okay, so there's a Ferris wheel, right?
Wow.
Crazy, there's circles. Isn't that wild? All right, what do we know about the Ferris wheel?
It's 30 feet
It's a circle.
off the ground.
Okay, so the boarding platform down here
Yeah.
is 30 feet tall. Yeah, this is a big ass Ferris wheel. And the diameter of the thing is how far?
520 feet.
520 feet, which pegs the middle here at how high?
550. 550.
Okay, that pegs the top at 550.
Wait, what?
You just picked
No.
that center.
It's
520.
It's 520.
What? No, sorry,
Why'd you put
the
520?
diameter is 520.
Right.
Oh,
what do you
okay.
get
And so the top is 30 more than 520 is 550.
Wait, what?
Yeah. Yeah.
And where's the middle here? How high is that?
It's half.
Whatever.
Half plus 30.
Half of that plus 30.
Yeah.
290.
Wait,
Yeah.
what?
Wait, what?
What's this going
We're on Ferris.
Wait,
Would it help if I labeled my
there
Ferris
you
wheel
go.
this way?
Yeah.
Okay, so the little platform's 30 feet tall,
Get rid of the 520 in the middle. There you go.
and then the whole thing's 520 feet in diameter.
Right.
There you go.
And so, starting at 30, then up 520 more is 550 at the top.
Right. Where the
It's-
hell is the 290?
What the hell is the 290?
520 divided by 2 is 260.
Yeah,
Plus 30.
but it starts at 30.
Oh, so you're starting from all the way down to the
Yeah,
bottom.
so the ground is 0,
Okay,
30 is the top of the boarding platform,
okay.
290 is the middle of the Ferris wheel,
Plus.
and then 550 is the top of the Ferris wheel. Are you good with those? Okay. What?
I said axes, that's what I said, math terms, so I
Cool.
said if you
Okay.
shifted your graph up.
Okay,
instead of
so
doing that.
we need to add to this knowledge, the wheel completes a full rev every 30 minutes.
Okay.
Okay, 30 minutes? Okay, and then I'm supposed to sketch a graph of f of t, which is h of t. Let's call it h of t, which is your height above the ground from the time you board at t is 0 until you exit after 2 full revs.
Chill.
Cool this?
Hold on.
No.
Okay,
At 2 full res.
here's you. T is
It's
0,
at the bottom again. Yeah.
right? So you're on. God, I hope you're going to get off the Ferris wheel at the bottom again, right?
Well,
Don't
it said
jump
it
from
didn't-
Ferris
Didn't
wheels.
ask what the
Bad
height
idea.
was, what your height was after 2 full.
No, it says sketch a graph of your height.
Oh, okay.
So
Wait, looks like a 6 foot, right?
h of t, right, is some function.
Your height of time. Over time.
Okay, so I'm going to do this. I'm going to put time on this axis and height on this axis, and then I'm going to try to draw h of t.
This is sine wave,
Where are you
boy.
going?
Okay. So 30, 550.
Okay, that was rude.
Okay, so
Damn!
30 at the bottom, 550 at the top, and what?
And 290 in the middle.
And 290 in the middle.
That's the midline, boy.
And 290 is the midline. Very nice. Okay, where do I start?
At 30.
At 30 at time 0, right?
Yeah.
Okay, then what?
What are you doing?
Okay, how about tell me at 15 minutes, where are you? Okay. You'll be up here, right?
Yeah.
So in the time between 0 and 15, what happened?
You went up.
You went up.
It was constant.
Okay, so there's 15, there's a dot,
Yeah.
right?
Yeah.
So notice at the bottom, right, you're gaining height pretty slowly. You guys see that? And then over here, you're gaining height pretty quickly. And then it slows down again.
So
Right.
it's like an S.
So yeah, that's going to look like an X, right? And then what's going to happen in the next 15 minutes between time is 15 and time is 30?
Go back down to 30.
You're going to go back down in exactly the mirror image, right?
Mhm.
So you're going to end up back down here, and you're going to do this. Oops, shit. You're going to do that. And there's, what? Not a coincidence that this looks like a sine wave, right? Because it is. Because the thing you're keeping track of, right, is the vertical going around a circle. So this should look like sine.
Yeah.
It shifted and moved around a little bit, but it should look roughly like sine. So what else do you need for this thing?
Another.
Yeah, you need one more little whoop-de-doo, right? So you need an up and a down.
That one's higher.
Whatever.
Totally.
Up to drawing.
Oh,
When's this one happen?
it's one of those cool Ferris wheels that like turns up and down.
45?
45 minutes there, and this guy is
And I'll flip you up a little bit.
60
You're
minutes.
upside
Who
down.
spends an hour on a Ferris wheel?
Who spends an hour on a Ferris wheel? Is
People who
a
spend a lot of money on the ticket to that Ferris wheel, spend a lot of time on it.
You get really high.
Ferris
He's got a point.
That's a slow Ferris wheel though.
Cool? Questions? Steals?
Was that it?
I think I was.
That's it. That's what I wanted there.
Just slow.
What is the, while we're here, what's the domain of this function?
Why?
No.
There you
All
go.
nothing, all real
It goes to
numbers above
zero
zero.
to
positive numbers?
60.
So
Or
it
wherever
starts
you
at
get
time
off.
0, right?
Yeah.
And then where does this thing stop making sense?
60.
60, because you got off the Ferris wheel, right?
Okay.
So this thing applies when you're on the Ferris wheel between times 0 and times 60. You guys cool with that?
If you were on that Ferris wheel forever, it would be.
Yeah, if you wanted the model of
0 to
the
10.
Ferris wheel itself, right? Like you're going to peg one of the chairs and let it run forever. Yeah, then it might be for all time, right? T is 0 might be when you turned it on the first time. And yeah, just assume it won't break down, which is, of course, a poor assumption. It's a model, right? So mathematical models are all wrong. It's just that some of them are useful for a while. Cool?